Now we come towards the Moseley's law. Well, Moseley's law is a modification to Mendeleev's law. Mendeleev and Moseley both corrected the periodic table by explaining the properties of elements. So according to Mendeleev, you find that the physical and chemical properties of the elements are the periodic function of their atomic weight. But there is a defect in this particular statement because many elements are not, that is, found in the vacancies in the periodic table. So Moseley suggested that the atomic number is a fundamental property, that is, the physical and chemical properties of the elements are the periodic function of their atomic number. So we will relate the frequency or wavelength given out from an atom with the atomic number. This law gives a relationship between frequency of the characteristic X-rays and atomic number Z of the target. According to this law, the frequency of spectral line in X-ray spectrum varies as a square of atomic number of the element. So frequency emitted is under root nu is equal to A into Z minus B, where A is proportionality constant, B is a screening constant. The atomic number determines the physical and chemical properties of the element. This is what I have explained earlier in the Moseley's law. Now there are two types of graphs are indicated. One is Z versus under root nu and other is Z versus nu. So two graphs are indicated. In the left graph, a slope is A, and we are referring K beta line and K alpha line, and they are related to atomic number and frequency. So as atomic number for the K beta line go on increasing, we will find that under root of frequency will also increase. And the same statement we can give for K alpha lines. But in the second graph, that is the right hand side graph, we are finding that as Z is increasing and it reaches to a peak value, the frequency also reaches to a peak value. The atomic number determines the physical and chemical properties of an element. The atoms must be arranged according to atomic number in periodic table. Then we will find that most of the vacant places will be filled and not by atomic weight. He corrected position of potassium, argon, cobalt, and nickel in the periodic table. He predicted the new element with Z equal to 43, 61, 72, and 75, which were discovered later. The slope of under root nu and Z curve is equal to a constant A. The value of A is maximum for K series. That is when electron is excited from n is equal to 1 state. Nu is proportional to Z minus 1 square rather than Z square. It is explained by partial shielding of nuclear charge by the outer electron remaining in K shell. The wavelength of characteristic spectrum of X-rays is given by formula 1 over lambda is equal to R into Z minus B whole square into 1 over N1 square minus 1 over N2 square. And this statement is in accordance with the Bohr's model of atom. Lambda is the wavelength given out, and 1 over lambda, that is reciprocal of wavelength, is also known as the wave number, that is nu bar, or we can write bar nu. R is the Rydberg constant, Z is atomic number, B is the screening constant, and when we write N1 and N2, it is the N1 and N2 are the principal quantum numbers, that is electron jump from N2 to N1. Now B is equal to 1. If B is 1, for K series, B will be 7.4. For L series, B will be 19.2. And similarly for M series, we can have another number. So diffraction of X-rays, that is bending of X-rays, at the corners of the object. Using this principle, we are in position to estimate the separation among the atoms in the crystal. That is, atoms are arranged in a crystal in three-dimensional repeated pattern. The axes are called the lattices. The point where atoms are arranged are called the lattice points, and the distance between the two atoms on any of the three axes is called the lattice parameter. So lattice parameter was found by using the X-ray diffraction by Bragg. So Bragg suggested that n lambda is equal to 2d sine theta, where n is the diffraction order, lambda is the wavelength emitted from the particular plane of the crystal. So it is n lambda is equal to 2d sine theta, and d is the distance between the two planes, and theta is the glancing angle. Diffraction of X-rays by a crystal was discovered in 1912 by von Lau. So basically he explained about the Lau spots. The diffraction of X-rays is possible because interatomic spacings in a crystal is of the order of wavelength of X-rays. That is, interatomic spacing will be about 1 angstrom unit because the wavelength of X-rays is found to be 1 angstrom unit. The diffraction of X-rays takes place according to the Bragg's law, as I have suggested. 2d sine theta is equal to n lambda, where n is the number of plane and d is the distance between the two planes, and theta is the glancing angle, and lambda is the wavelength emitted from the particular plane of the crystal. This helps to determine the crystal structure and the wavelength of X-rays. Now there are uses of X-rays, like X-rays are used in surgery, in radiography, in radiotherapy. So X-rays pass through flesh but are stopped by bones. So they are used to detect fractures, the foreign bodies, diseased organs. The photograph obtained is called radiograph, and the procedure is called the radiography. Then comes the radiotherapy, that is the treatment of certain diseases with the help of X-rays. The X-rays can kill the diseased tissues of the body. They are used to cure skin disease, malignant tumors, etc. In industry, they are used to detect that is defects in the motor tires, the golf and tennis balls, wood, wireless valves, used to test the uniformity of detecting the presence of pearls in the oysters.